So with this prototype of the tension chair, you can see that the excess straps pose quite a problem. I don't want to cut them off because then that breaks the value of circularity, where these straps should be reusable after the end of the life of the chair. So I don't want to cut the straps because I want to keep them intact. But it's a bit ugly and impractical to have these dangling excess straps. So I need to design a 3D printed part that will keep my straps nice and tidy. So let's go into Fusion and design a solution. As you can see, I'm modeling the design parametrically, or in other words, using parameters, so that the design is more flexible and can be adapted by whoever downloads the design. 3D printing allows you to produce complex curved geometry. I need to make sure at this point that the wall thickness is not too thin for 3D printing. Adding fillets and rounds helps to reduce point stress at the corners and edges. This is also useful for 3D printing because it can help to avoid thin layers and single strands of material. Here you can see the design is prismic, meaning it has a continuous cross-section. However, there is a slot available for the strap to pass through. This part will need to be oriented so that the opening of the slot faces upwards and not downwards, so as to avoid support material. This design is simple enough for 3D printing. It has no overhangs, requires no support material, and the wall thicknesses should be sufficient for the job. Now we've modeled our design, it's time to set it up ready for 3D print. Here we have the Prusa i3, a very reliable, very popular brand of 3D printer, but any kind of FDM printer will work for this kind of print. To set this file up, we're going to be using Prusa's own slicing software called Prusa Slicer, but any kind of slicing program will work. Just make sure that all of the printer settings, like the nozzle diameter, are correct in your slicer program. You can download the slicer software for Mac, Linux, or PC from Prusa's website. Once the part had been sliced, it was time to load it up on an SD card and put it on to print. Now that the part has been designed, printed, and tested, it's time to share the STL file on the Wikifactory project, so that others can print it for themselves. I will also upload the Fusion 360 file, so that the parameters can be changed to fit whichever kind of strap the user might have. If they download the STL, the model will be ready for print, as I've just tested, but they will need to slice it for their own printer and printer settings. If they choose to edit the Fusion file, they'll in all likelihood need to export the file as an STL or an OBJ in order to import into the slicer. These technical steps, although routine for any veteran 3D printing technician, could be a communication and user experience challenge for the designer if the user is totally unfamiliar with 3D printing. That is why I will need to continuously update my documentation and assembly guide for the project. So what are the key takeaways? The design of the clip made use of the capacity of the printer to produce complex curvatures, but I was careful to ensure the orientation was such that it did not require support material and the wall thickness was not too thin. I tested the print myself on an FDM printer to ensure it was possible to be printed. then shared the STL file and parametric model on the project page so that the design was accessible and adaptable. Lastly, I will need to continuously update the documentation and assembly guides for transparency and communication.